Hi, my name is Thomas Kim. In this session, we will implement variables in our scripting language. At the end of this session, we will create this program. I started a program that I prepared in advance, and we can load sample programs like this. This is Apple is assigned, 4 is assigned to Apple, and Apple count, 10 is assigned to Apple count, 6 is assigned to banana, and banana count is 10. Then we compute the total price like this, Apple times Apple count, banana times banana count, and plus. Then total discounted price is total times 0.9. and total count and total and discounted price are displayed at this line. If we run it, then the price is displayed here. 10 integer, 90 double. Double means because we point double floating point number here, discount becomes double data type. If we change it, for example, Apple is like 20. Then if we run again, then the price gets changed. Say then this is the same program in Korean. Some variables, for example, this is Apple count is 6, Apple is 6, and Apple count is 10. So Korean text and English, Korean variable names and English variable names are intermixed. Then we can run this program in the same manner. And then Japanese text, this is all variable names are in Japanese, and we can run it like this, the same way. And also Chinese, this is program in Chinese variable names. English and Chinese is intermixed. Then if we run it, then the price is displayed like this. And also all international languages, the first part, this part is English, and this part is Japanese, and this part is Korean, and this part is Chinese. Actually, this program supports 70 languages, all in Unicode, and can be intermixed. Now, if I run this program, this sample international dot, then the results are displayed this way. We can change, for example, like 25 like this. Then if we run it, then the values are updated. At the end of session, we will create this kind of program, and we will implement variables. This support not only integer, as you see integer, double, we can also define Boolean values like sorry, for example, sorry, total. We can say, we can compare like Apple is greater than banana, for example. Then if we run it, then we have to display sorry. To display sorry like this, we can display then true. Apple is greater than banana. True is, this is like Boolean expressions. So we can assign Boolean values too, and if we want to things, we can true is, we can also assign Boolean values. This is Boolean value. If we, and then we display thank, then the Boolean value thank is displayed. If we set it false, then thank becomes false. This way we can also assign Boolean values. At the end of session, we will create this programming language. Please be visit my YouTube channel and this YouTube video. We will download the sample source code here by clicking download source code link. Sample code will be downloaded in your download folder like this. Then please unzip it. Then in the unzip folder, copy this, copy, then paste it to your working folder. Please rename it to 10. Rename to solution 10. Then open it in Visual Studio. Open the solution from in Visual Studio like this. In your working folder, copy solution 10, open it. When solution is loaded, then press Ctrl F5 to double check that you can build my previous solution properly. If you have problem in building this solution, then you probably have to install Bison and Flex and make some settings. If you haven't installed Bison and Flex, please watch this video installing Bison and Flex on Windows 3 different way. Please refer to this video about how to install Bison and Flex. In this section of video, you should be successfully build the solution like this. If you cannot build, you probably have to refer to my other videos. Then close the solution, and we will make a few changes before we further proceed. First, in Solution Explorer, click Bison and Flex. Then click parser Y. I will make a few changes here. First, scroll down here. Copy integer like this. Then Ctrl H. Copy integer, Ctrl H. Then here type in integer. Type like integer. Then please select A. It should be selected. Also, it should be selected like this. Both are selected, and both are unselected, and both are selected. Make sure both are selected. Also select current project. Then click this button, replace all. Then it will give a warning, but no problem. Just yes. Okay. Then you should have 195 occurrences replaced. Click OK. Don't worry. Then save. And we will change one thing more. Please scroll up here. Copy TK and type. Ctrl H again. Then TK and type here. In the same manner, type. Okay. Then replace all. It will yes. Just continue. Then 10 occurrences replaced. Then close. Then save. Then right click. Compile. Okay, it should build successfully. Then close it. Then in the class view, LIB parser once again, talk play pun. Click parser manager, double click it. Then here, scroll down. I don't like it, so we will change name like this. Pushback result, pushback int, just like a pushback result. Then save it. Then here pushback. Just click any function. I click the pushback error message. Click any function. Then here we have to remove BLEN. Then DBLE. then here intg, save all. Then in solution explorer, once again, header file, base, parser.base. Okay, please open this file, parser_base. Here we are going to add a few changes. If def mx64 like this, then type def long integer, type like this, else type def int integer, then and if like this. Please type in at the end of the file here, see, please type save, please save it, then click parser, right click, then rebuild only lib parser. Okay, we will make changes. Double click, it should be like this. We have to fix like this. Now save it. Now rebuild. Okay, you should build with no warnings, cleanly. Okay, then click class view, code editor, then code editor app, init instance. Okay, so scroll down. I will change it to like this: talk, play, fun, and I would change it to 16. Control S, save all. Now build a solution. In solution, close all. We don't need any, close all document, all files. Control F5. You should successfully build your application like this. And now close it. Now change it to x86, different platform. This is 32-bit application. Now press Ctrl F5 again to double check that it works. This solution works both on 64-bit and 32-bit. Ctrl F5 just once again. Okay, we should be able to build in both 64-bit and 32-bit application. Now close it, move it back to x64-bit like this. Now we are going to do the real work. Now open the bison flex file once again, parser y file once again. Now we are implementing variables in our application. Scroll down here. I will try to explain as detailed as possible. If you have questions, if you have problem to follow with me, please leave your comment. Then I will try to answer as soon as possible. Token, declare token intg undf name. Undf means undefined name. Okay, undefined name. And define another token intg. This is also intg tag type. Semantic value type should be intg. Now it should be var boolean. It means boolean, bool variable. Okay. Then token intg var intz. We will use it as int integer variable. Okay. Then token here intz var dble. Say double variable. Okay. Please define like this. Then we are making we are going to use this undefined name. Say here, you say undef undef name equal. Then we will fill more here expr blen. Okay. Then semicolon like this. Now we copy it once again like this. Then it should be intz dble like this. Save it. Say when we find a name, undefined name, and we find the equal, and we find a Boolean expression, then we are going to assign we create new variable of type of Boolean. Then we assign the Boolean expression, the value of Boolean expression to the new variable like this. Save it. And then say in this Boolean expression here, like the var blen. It means we got Boolean expression variable. Then we will make more code here. For the time being, just disable it like this. Copy. Then put it in intz expr dble here. We have to change it dble. Okay, we will fix it later. Just put it as placeholder. Then intz here. Then intz. Just save like this. Then we also need to lexer. Say the very first thing we have to do is we have to define new operator, assignment operator here. Please note that we use assignment operator. Here we are using assignment operator, so we need to have assignment operator like this. We have to add this part will be passed here. Also we need to have variable names. We will use letter. Letters means letter one or more times one or more of letter, then digit or letter 0 or more. It means something like this. And letter is single quote, basic Latin, Latin 1, Latin extended, and this gives all kind of Hebrew, Arabic, Syriac, Arabic supplement, Tana, all kind of characters, about 70 human languages, Hangul, Jamo, and Japanese, Chinese. It supports about 70 human languages that Unicode can support. So we will use letters as variable name. You can put it here or above here. LETTER, letters. Now we are returning here. Letters will be variable names. We need to register this variable name. So if we have to register variable name string to our database, to do that, click class view, scroll down, lib parser, talk play pun here, click parser manager here. We are going to add one more. Just copy this text. Then we will name it std string tmp name. tmp means temporary, okay? Temporary name, we make a deq. We can use it as vector too, but sometimes deq is sometimes more handy, so I added it. And another thing, we need to map. We need include map, save it. Then we will add one more here, std map, std w string will be key, then result, then m variable. Okay, save it. Then we say here we are going to save letters name to this class. So this will contain, we will have like this, we will add a function here, integer push back tmp name, like this, constant character pointer name, like this. Then copy this text, and we are going to implement it, pushback result here. Then paste it. Okay. Now here we are adding tmp name here. Pushback. Then we are adding name, but it should be double string, so we have to convert it double character t, like this, name. Okay, then we have to return value. We are return this m size -1. Okay, this is last index, index of last element. This is index of last element. Okay, so it returns store name to tmp name, and returns last index, returns the index of the last, returns the index of the added name. I will do like this. Save it. Then we can get in here, we can get YYL bar intz, see, YY extra means the instance of this parser manager. YY extra is an instance of parser manager. So we have parser manager pushback name here. We can call like this, pushback name. Then this is character pointer. YY text is character pointer. Okay, so we put like this. Now we have to determine if this name is variable name, defined name, or undefined name. Okay, we have to tell that. So to do that, we will do like this. Here we will name like int is index get token. Okay, get token. We'll say int is index name idx. Now we copy this and put it anywhere. I will just put it here. Okay, now paste it here. Copy this. Now we are searching, we are trying to find auto, ITR, this, and variable. We are looking up variable map, find. Then we need index. We need to find the key variable name. Variable name is saved. Saved TMP name, and each index is this name index. Name IDX. Okay. So it should be changed to typecast to size T. Size T like this. We have to fix like this. If name is found, means ITR is not this variable, and then we found the name. Okay, so then we return int integer. We actually don't need this because ITR second type. We just return like this. Else, then we failed to find the variable. Return tkn un. Sorry, we need to build. Click Solution Explorer, right click parser, compile. Okay. Okay, then here then we have tkn un. You should have tkn undefined un f name. Let's double check. This name should be UNDF. Okay, UNDF name. Here. UNDF name. TKN. Okay, save it. Just ignore it. It means name. Name is not yet registered as a variable name. Okay, name is not yet registered as a variable name. If we already found here, it means we found the name in the variable map or dictionary. Okay, just to save it. Now build it. Try Ctrl F7. Okay, it builds. Okay, then this squiggle will goes away if we say parser, click parser, compile. Then it will go away. Okay, then from here Lex again. Then we can call this. We can find return yy extra again. Yy extra. This function name is get token. Okay, so get token. We need to provide this index. This is token name index. Okay, token name index. Then it should be int. Okay, save it. Now right click, rebuild. Okay, it should build successfully. It built successfully. Then if it returns, if get token fails, if get token fails to find the name, then it returns UNDF name. Okay, here. If it fails to find, it reaches here at this point, then we have to register this name as variable boolean, for example. Then here we will add a function, void add variable, like this, and int integer, it should be name index name idx, then bool value, like this. Okay, then another thing like this, then it should be intg integer, then this is double. Okay, save it, save them, then copy them all, copy here, and you can paste it anywhere. Actually, we will just put it here, then copy, we will start with this one. We are adding variable to our variable map. To do that, we need to create result, RLT type will be, this is in boolean type, so tkn var boolean. Okay, RLT value boolean, we are saving value, boolean value, then we register this m metric m variable here, insert, we are inserting like this. Okay, here the first is key, the variable name, so this should be variable name like this. Okay, so this is m tmp name, then variable index name idx. Okay, then it should be size t again, size t, then this is variable name. Now this result, okay, RLT std move RLT. About std move, I will talk in some other videos. I already talk about these things, but I will give you more details in some other videos in future. Then close bracket, then save like this. Okay, I will make it bigger for easier read. Please pause and try to understand what it means. We are inserting a key value pair here. Now we copy it, copy the code here, delete, then enter, like this. This is integer value, so it should be tkn intg, and it should be intg. Okay, okay, now we copy once again, and this is double, this type is double, so it should be dble, then it should be dble, save, then it's done. We are adding variables to variable map. Save this, then here now we can add variables like this. Okay, pm add variable. Like the first is in this value is index $1, then this is $3, like this. Okay, then we copy it and we can just paste it. Now we registered variable. Okay, then here we want variable, then we want to assign it to expression. So we need to things like this, get variable. Okay, so we are, this is adding, now we are getting variable like
you
this.
have new mail.
Pull get var plen integer name idx. This gives boolean value. This is integer intz. No, it should be integer, then it should be intz. Okay, then it should be double, then its name should be double, dble. Okay, now copy these, copy all these, copy these, save these, see, then here paste, copy this part, then add here, save. Okay, then we will also put it here. Okay, this part is easier. We can just return n variable, then we need key this and temp, then name idx. Okay, it also should be size t, okay, then it returns result, then value, then this is, it returns boolean value, so it should be boolean. Okay, just copy this, copy this text, copy, paste. Now we are returning integer, so it should be intg. Save it. Now copy this part once again, delete this, paste. Now we are returning double value here, dbl double value, so it should be db. Okay, save. We save, then come back here. Now we can update this like this, ppm get var plen. This gives index, named index here, $1. Save it. Save. We copy it, then go to double here. You can put it, paste, sorry, var dble. Okay, so it should be dble. Now copy this once again, go to integer here, and it should be dbl var intg. This is for integer variable, so it should be intg. Okay, save it. So we are retrieving value. okay, from map. Then let's see, almost done. Then we can reassign. Okay, we have to reassign. Sometimes we can change the variable name, value of variable here. No, we can't do this. We declare another token. Here, declare like this. Token intg var variables like this. No, not this. Here, like this. Okay, expr variables like this. expr var. I would say expr var. Please note that this is integer type. Then we can put it like this. expr vars. I would say vars. Okay. Then var blen var intg var dble. Okay, just save it. Then here, instead of this, expr vars. Okay, like this. Save it. We should fix it to vars, expr vars. Okay. No. Left side. I would say left side. Left hand side variables. I will rename like this. Copy, save. I changed, sorry. Like this. Left hand side means we can assign. Okay. Also save this. Now we can reassign. We have to reassign here. Select this again. This is assignment. This is add. When we add variables, we have done this. Now we can reassign. Paste. Assign to var. Assign to variable. Like this. Copy once again. Copy again. Now we copy the whole text. Copy. Then here. No. Here. Okay. Then it's very simple. Like this. We need to get. You can just say auto. We will get result. Then RLT here. This and variable. No, we need this. Here. And m variable. This. No. M variable. This. And tmp here, name, index. It should be of size. It should be size t. It returns the key of the name here. Then okay, type like this. RLT. We have to change. Okay, we have to change type. This is boolean, so tkn var boolean. Okay, RLT value. We are reassigning value to. Okay, Now copy this text. We are reassigning. This is integer. Okay, so it should be intg, and we are assigning to intg integer. Save it. Now we are doing once again here. We are assigning double. Here type is dvle double, and it should be dvle. Saved. Now we can update it here. It should be assign ASIGN to VAR like this. Okay, then copy it. We are reassigning to variables. Save. Control F7. We should not have warning here. Okay, it's done cleanly. Then let's run it. Save. I think we have done most. Let's run it. Control F5. While it is building, I will copy some prepared sample program here. Also, when you download the source code next time, then you will have these files. Okay, it's running. Let's load the files. Open. And not here. Here. This is 64-bit. Here. And we can run. Let's try with English first. Let's run it. Syntax error. Unexpected undefined name. Oh, I forgot one thing very important. Okay, I forgot one thing very important. Here, I will open this file in edit with Notepad. Okay, I opened this file, and if you see encoding, it is UCS2 LE, Little Endian Bomb Marker. BOM is bomb marker. For more about the bomb marker, please leave it to internet. I will give the link. So we have to fix this problem. I will first copy. I will first fix, then I will let you know. I will help you understand. I copy, and here. I will paste it here. Then I will copy this file, this part. Then header. Here, I will paste it. I will explain this code after testing first. Save it. Then class. Here, run. Here. Here. Handle. Byte ordering mark. Then input file. I will do like this. I will build once again. Please wait. In your case, you do not have this code, so I will explain. Okay, it runs. Then I load again. Then I run it. Total. This total. I will display it. Okay, it runs. Okay, I will load another sample. Korean text. This is Korean sample. I will run it. Okay, it runs. Now I will explain what is 본막. Okay, I will explain what is 본막. Here, please refer to this YouTube text. It is byte ordering mark UTF-16. So when we save a file, so I will open this file, source file, for example. Open it. It says encoding. Please, UCS2 LE means little endian. Please watch it carefully. Little endian BOM, byte ordering mark, means this file, the very first 2 byte. The very first 2 byte is not hidden here, not displayed, is 본막. Okay, so the very first 2 byte is this 본막, little endian system. The very first 2 byte is 본막. So when we when we open file, we first open the file here, input file. We open the input file here. Then we do things like this. First, we declare short B mark like this, and I declare another size B mark. I declare one variable of type short. Then size T size F read, I read S, I read the file contents. Buffer means this variable, like a B mark like this. We are reading 2 bytes. Reading 2 bytes. Okay. Then size of buffer, you can say size of B mark. Okay. Then size of element, size of B mark. Okay. Then element count, 1 element. File stream, input file. We are doing like this. Okay. So this function returns this function returns number of bytes. Then it can be, if function succeeds, then size is size of B mark. Okay. If this function succeeds, it means if function reads 2 bytes. Then if the contents of the first 2 bytes, the B mark is first 2 bytes. First 2 bytes of the file. Okay. Here B mark is short. First 2 byte is in hexadecimal 0x. This 본막. Okay, I will show you 본막. It is represented hexadecimal like this. FF, FE. FE, okay. Then it is bookmark, so we can skip it. If it is not, then we restore. We read 2 byte. If it is the first 2 byte is not bookmark, if the first 2 byte is not BOM, byte order mark, then restore file position to the beginning. Then we can do this f seek, okay. Then file stream input file, then offset 0, seek from, we are seeking from the start of the file, seek set, it restores, return file position to the start, okay. It means this, if the first 2 byte is not byte ordering, okay. So otherwise we just skip. Then if we run it, this is actually the same as before. I made a mistake here. The documentation says FFLE, this is low byte, higher byte, this is low byte. So this is low byte, least significant byte, this is most significant byte. So we have to change order, not FF, but FEFF. Okay, we have to set like this. Okay, so this is low byte, this is high byte, low byte, high byte, low byte. When we define it in C++ code, we have to change the order like this, okay. So we have to learn, we have to fix like this and have to run again. Okay, let's test once again. International. If we run it, it successfully runs. Korean, it successfully runs, okay. So we have to fix like this, and this part of code we can delete it and we can just put it here. So byte ordering mark is the code I just explained, okay. This is the code I just explained, okay. So please refer to more about this document. Save it. So another thing finally we need to do is handling literal. We haven't, in our previous video, we haven't defined, this is the literal boolean, but we haven't assigned it yet. We have to handle this. In case of literal integer, it will be handled, but we need to assign literal boolean. To do that, we need to name something like this. I will say bool true. I will just put it here. Bool true. We will define it. Then TRUE. Okay, so I'm making it to like this, but it should be 2 byte null character. Also we put it here, then we have to put another null, then U, then another null, then E, then another null. Because we are scanning Unicode text, we always has to read even bytes. T R U E. This is true. Now Boolean false. Bool FALSE. Okay, it should be FALSE. Then we can do like this. 1, then 0. Okay. A 0. Okay. L, then 0, then S 0. Okay. E, then 0. Okay, we defined two F A L S E. Okay, then we can say uppercase, 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 uppercase. Save them. Okay, now come here, come here, come here, come here, come here. Here, before this this is specific, we can put it anywhere, but I will put it here. See here, bool true. Okay, then we can simply return tkn. No, we have to set true. YYL file BLEN. Okay, we say true, then return tkn liv, not liv, literal lit blen, boolean. Okay, now we copy it once again, then literal false, boolean false, false, then it should be false, then that's it. With this, sorry, Control S, now rebuild all. Let's build this file, Control F7, just Control F7. Okay, it builds successfully. Control F7 and Control F7, YY Control F7. Now it builds. Now Control F5 to build the whole solution. Wow, it's built. Now I wrote the sample files like this. Then I can run. Okay. And English. And this is Boolean value. If we run it, false. Okay. Now we can also define like this. Here. Lovely. Lovely. FALSE. Okay, we display LOVELY. Lovely. Lovely is still true. Okay, it will be displayed true. Let's run. False, false, false. Okay. Pretty. I see. Pretty. TRUE. Okay. The case is ignored for Boolean type. PRETTY to display. Okay, true. So you can load any international languages, 70. You can intermix 70 international languages in a single program. You can use them as variable names like this. So everything should work. We we have to add one more routines to say, please understand that we use the TMP name as temporary name container to hold the variable names temporarily. We have to remove them. So to do that, I will add one more function here. Void cleanup TMP name. I add one function here. Then copy. Then we can put it anywhere. I will put it here. Like this. Then here we have the clean temporary name. And TMP name clear. Okay. Save it. Then save all. Then here we have to delete the ppm clean up tmp name. Okay, you should not forget this. Save this. Let's see. Clean up tmp names. Clean up tmp names. Okay, save it. Now rebuild. Control F5. Finally, okay, it builds and runs successfully, and it should have no problem now. The string, the temporary variables should be cleaned up each time. These are statement, okay, because statement, all statement ends with the semicolon. So after each statement completed, then we have to clean up the temporary names. That's it. Let's wrap up this session, and next session I will implement loop, if, and do loop, for loop, things like that. Thank you for watching.